All right, so to review the hot notebook stuff, okay? Remember, if you did not turn it in yesterday, then it's a 0 unless it's sitting on my desk right now in this very moment, okay? For the first, I'm looking at the properties first, okay? The first one was the multiplicative identity, or some of you put identity of multiplication. That's fine. Letter B was distributive property. C is associative. The grouping changes, so it's the associative property of addition. D is symmetric. If this something equals y, then y equals that something. Symmetric is like the butterfly. If I were to fold the paper, it would match when you open it up, okay? So D is the symmetric property. E is transitive.
Would D, then 2i plus 5i equals y, then y equals 5i plus 2i? Would that have still been symmetric, or would that have been? Yeah.
What?
Like,
I got to write. I have to see it. All right, y equals.
well, like that's the second part.
So if like that. No, that's not reflexive. Reflexive is if x equals 6, then x equals 6. Reflexive is if it's the same thing, something equal to itself. That's the reflexive property. D is symmetric because it has flipped over. The 2i plus 5i and the y have swapped places. So that's why D is symmetric.
Both ways it's still going to be symmetric.
Yes, it's still symmetric. Okay. If it were substitution, because some of you came to me before you turned this in and you said, what if this is the substitution? No, substitution is really substituting. If x equals 6, then it would be like 2x plus 6 equals 2 times 6 plus 6. It is where you're actually seeing the value substituted in for a variable, okay? But D is symmetric. Looking at the next one, any other questions on the properties? Properties are cut and dry, and I'm going to tell you right now, if the state is sending us this for you guys to have extra practice, you better know your properties. Okay, that's the way we are thinking, is if the state's sending it to us, then it's important. You better be ready. The second page, factoring, folks, it said factor. Some of you were taking square roots of, and I was like, what? It's factoring, okay? The answer to A is 3 times the quantity, 2x minus 3. Now, keep in mind, I will not accept any more of these for a grade, because you could just sit right there, copy the answers, and go, here you go, Miss Perry. Take 10 points off. It's a 90. I don't care. I'm not accepting them after this. I mean, I'm not accepting them now at all. Again, A, 3 times the quantity, 2x minus 3 times the quantity, 4x squared plus 6x plus 9. And I tried to be very specific in telling you what you did wrong, if you got close or if you didn't get close. B was sum of cubes, okay? You would have had 5x plus 9y times the quantity, 25x squared minus 45xy plus 81y squared. Okay? Sum of cubes. C, you had to factor out the GCF first, then it was difference of squares. This was weird, but it's totally doable. 9 times the quantity. 5x cubed minus 3y to the 5th times the quantity. 5x cubed plus 3y to the 5th. Yes. One more time. 9 times the quantity. 5x cubed minus 3y to the 5th times the quantity. 5x cubed plus 3y to the 5th. And D, pardon? That was C. D is 3y times the quantity, x plus 6 times the quantity, x minus 3. Some of you factored out the GCF and then you left it and you didn't factor out the rest of it, okay? And that's just a careless mistake. That's all it is, yes. Uh-huh. Sure. 3 times the quantity, 2x minus 3, times the quantity, 4x squared, plus 6x plus 9. 9. Are there problems you need to see from this page? See? See? All right, let's look at it. 225, x to the 6th minus 81y to the 10th. Did you notice that we're dealing with numbers that we haven't typically dealt with before? Okay, this is like factoring on steroids, is what I think it looks like. But I do notice that 225 is a perfect square. I notice that 81 is a perfect square, and it's only 2 terms with a minus sign in the middle. Chances are this is going to be a difference of squares. Now, but what about x to the 6th and y to the 10th? Those aren't perfect squares. No, they're not. But when you take the square root of an even exponent, folks, I want you to think about that. What's the square root of x to the 6th? How do you know that? Because your index is 2, it's there but not there, and we're dividing. So if it's evenly divisible by 2, then it is a perfect square of sorts. Okay? Now, you look at C and you go, oh, well, hey, perfect squares, 225 and 81. But what's the first thing you have to try to factor out every single time? The GCF. So we factor out the GCF, which is 9. And that leaves us with, by my work, 25 x to the 6th minus 9 y to the 10th. Okay? And then I look at it and I go, okay, I got 25 and I got 9. I know for sure that this is a difference of squares. So bring down your 9. What's the square root of 25x to the 6th? 5x to the 3rd. What's the square root of 9y to the 10th? 3y to the 5th. My signs have to be different. There you go. That's how you factor it. I would definitely look over this. Okay? Look over that. Think about it. Think about what you're looking at. But your factoring problems are not going to be just the simple y squared y minus 9 problems. It's going to be, it should be, an elevated factoring problem. Okay? This ain't we ain't in Kansas anymore, Dorothy. Okay? Questions? Wizard of Oz, thank you for making that connection. I had some people going. Thank you, Q. Dylan. Okay. My thing that I follow, because it's too much for me to remember, when it's the sum of cubes, I know, or difference of cubes. This is so stupid. This is just dumb, dumb, dumb. But this is how I remember it. If I had x cubed minus 8, that is a sub subtract symbol, correct? This is so dumb, but it helps me. Minus, plus, plus. I look at the word, but it helps me. And if I know that this is subtract, then this one has to be plus, minus, plus. This is the one I know, and then I default back to this. Sum of cubes is this, up here. Well, it's going to be 2 terms, and it's going to be like x cubed plus 8. 2 cubes with an addition in the middle. That's the sum of cubes. And then at the bottom would be difference of cubes, x cubed minus 8. And that's a very vanilla, very plain example. Okay, any other questions? These are good questions. These are the ones you need to ask. And start asking them now. Don't wait, and don't think, please don't think that you can go into this SOL and not look at anything. Not do a little bit of extra something, okay? Because you need to. You always need to. Other questions at all? Okay, put the hot notebooks away. I've got to show you the homework from the Elmo because it's too much. I'm just going to show it from the Elmo. So that means I can't record it, so you're going to miss this in the recording. I know you're all going to go home and watch. Here we go. All right. You guys are going to be glad that we are out of the land of functions, kind of, sort of. We are out of the land of domain and range, kind of, sort of. We're going to go through 6.1 and part of 6.2 today. Okay, remember that tomorrow your quiz, you have to be able to describe domain and range. Let's take a time out. Let's take an exit. Rest, stop. Okay, quiz tomorrow. Quiz tomorrow will be domain, range, in behavior, even versus odd degree. Remember those fancy examples that I printed off for you? I would definitely look over those. Even versus odd degree, what else? Domain, range, and behavior. Increasing and decreasing intervals. Okay, you know that parent function paper? Okay. You got to be able to find all of these things for linear equations, functions, quadratics, polynomials. Might throw a square root function in there. Bless you. Absolute value. And I might throw a piecewise in there. If I do, it's not a big deal. Okay. Probably. And you know what? And we've talked to, I don't need to record this. Folks, just to review this, you need to remember your rules of exponents, laws of exponents. This is just a review. You should already know these. When you multiply variables, and I'm talking variables with the same base, you add their exponents, okay? When you divide variables with the same base, you subtract when you have a power raised to a power, you multiply the exponents. Y'all feel like we're in Texas yet? So I'm so totally in the hammer lane. Driving fast with the cruise on. Get out of my way. And power raised to a power, you multiply the exponents, subtract the exponents, add the exponents with the same base. How can you not read that? How's that? Base? Is that better? I don't write everything in print. I'm like, I don't know why I do that. Sorry.
I did that too.
Haha. Sorry, Christian. I'm not perfect. Here we go. If you have a quantity raised to a power you kind of distribute the power. And multiply. You kind of distribute. Now, what's that mean? What is she talking about? And folks, I'm giving you a very quick, laws of exponents. If I were to have the quantity 3x to the 5th, y to the 4th, z, and I had that whole quantity raised to the 2nd power, bless you. Oh, I took it away from you, sorry. Sorry. You're going to distribute the power, okay? And that means it's going to become 3 squared x to the what? 10th. Y to the who? Z to the who? 2nd. Okay? And that's all that means. And you're not going to find it in the book that it says distribute. It's not going to tell you that. But that makes sense to me. Okay? Very quick review of laws of exponents, right? So what? Oh, well, but this is like from Algebra 1 rules of exponents. You're right. But here's one. Here's another one that we often leave off. Any number raised to the 0 power, any number, any variable, anything raised to the 0 power is equal to what? 1. Sometimes we forget about that. Okay? And then we got to think about it's this is a whole unit in Algebra 1, okay? And we're going to go over it in half a day. Half a day. All righty? Ready? So what are we going to do with this? We ready to roll? I can tell you are. You're so excited. So let's simplify. Let's take n squared over into the 10th. I probably do this different than whoever taught you in Algebra 1. But I know that I'm dividing these variables. Do you guys agree with that? All I do is this. Take my exponents and subtract them. And I'm not going from top to bottom. I'm taking the largest number, take away the smallest number. What's 10 minus 2? 8. Where will n to the 8th go? On the bottom. That's how I do it. I know 1's left on top. N to the 8th is on the bottom. Subtract the numbers. You remember this, don't you? Mm-hmm. That was a long time ago, wasn't it? Yeah. Subtract them. Put your answer where the largest exponent is. It's very simple. Mm-hmm. 10 minus 2 is 8. End of the 8th goes on the bottom. Yeah. Yeah. I could have done this. Right? And canceled that out, which leaves me 1. And I still get, is that what you're talking about? In essence, that's what I did. No, you don't have to write that down. Right? Okay? All right, here's another one. Let's look at 2a cubed plus 5a minus 7 minus a cubed minus 3a plus 2. What are we doing here? We are subtracting. Should we hear bells and whistles? Warning, warning, warning. Why would you hear warning, warning? We're subtracting a quantity, which means we've got to distribute that -1. I'm going to rewrite it. Some of you are never going to show extra steps. I get that. You go through and you make all of these their opposite. I'm going to rewrite 2a cubed plus 5a minus 7 minus a cubed plus 3a minus 2. What did I do? I just distributed that -1 that's invisible, okay? That -1 that's there but not there. And now what do we do, folks? Combine like terms. 2a cubed, put my a's together, and then my plain old numbers, my constants together. What do I end up with for my answer? A cubed plus 8a minus 9. How many of you got that? Are you glad we're back in the land of letters and numbers? I am. I like this better. Questions? Easy, right? Yeah? Pardon me? When I'm dividing variables with the same base, I'm actually subtracting their exponents, yes. Okay? All right? But all I'm doing here was just subtracting like terms. Yep. All right. Here's another one. What about this? 4x squared minus 9x plus 3 plus -2x squared plus 5x minus 6. Do that for me real quickly. (4x squared minus 2x squared is what? 2x squared minus 4x minus 3. How many of you had that? Questions? Was that a, I've got a question or I got it right? A delayed, I got it right. Okay, here we go. How about another one? (y times 4y squared plus 2y minus 3. Yep. Yes. Yes. Don't we have to go over those stupid properties at the beginning of every algebra class every time, every single year? And I hate that part, but we have to. But we got to go over this just to review. Hey, what property will we be using? Speaking of properties, distributive property. What do you end up with? -4y cubed minus 2y squared plus 3y. Question? Preguntas? Distribute, yeah, we already did. We already did. We distributed, we multiplied negative y to each of those terms. Okay, and do I have any like terms that I can combine now? Yes or no? No, I'm done. That's all I can do. And look, how many of you would go like, oh, well, I can factor out a GCF? If I did that, what would I be doing? Chasing my tail? I'd be doing the same thing. I'd just be going around in a big old circle. Okay? Don't do that. All right, here's another one. What example is this? 5? Okay. Well, bend your brain a little bit. A squared plus 3a minus 4 times a plus 2. I'm not going to say a word. I just want you to simplify. Do what? Just distribute. A times a squared is a cubed. A times 3a is 3a squared. A times negative 4 is negative 4a. Distribute the 2. All right, so that gives me 2a squared plus 6a minus 8. And then I combine my like terms. 4a, 6a, so I'm left with a cubed plus 5a squared plus 2a minus 8. How many of you had that? Facile, difficile? Facile. Y'all like this? Nope. Are you kidding me? No way. He said, is this all we're doing today? No. No. Do you have questions? This is a complete review from Algebra 1. Okay? You got to be able to do all types of things with all those exponents, variables, everything. No matter how many terms you're given. Yes? Get up and move around because y'all making me tired. All right, folks, here we go. So you got to be able to add, subtract, multiply, and divide polynomials, okay? So if I were to give you a problem that looked like this, see, y'all immediately just liven up. If you had 5a squared b minus 15ab, oh, I wish I could see, 3ab to the third plus 10a to the third b to the fourth over 5ab. Puzzled. This is when it would be so much easier to split this as 3 separate fractions, okay? Megan, how would I split this up? Because immediately I think you saw it. How would I split this up? Because, and this will help you guys for trig, to understand that these two expressions are equivalent to one another, okay? This is like having 4 quarters. This is like having a dollar bill. They look different, kinda, but it's the same value, okay? Now, when we do that, we have 3 separate problems that we can focus on. And we're not going to forget and make careless mistakes, because y'all know how I'm about careless mistakes. I make them and I hate to make them. Yep. You can do that. Yeah, you can do that. That would take, that's another way to skin the cat. Okay? Will you always be able to factor out a GCF? No. So just be aware of that. Absolutely, you can do that. It would if you factored out a GCF, then you would keep it as one fraction. Okay? Still should get the same answer though. This takes us back to the rules of exponents, and we're dividing fractions again. So 5 over 5, that's going to cancel out. What about my b's? My b's are going to cancel. And then I've got a squared over a. Folks, what are you left with? A on top. Well, I don't need to put it over 1. Minus, what's 15 divided by 5? 3, of course. My a's cancel. What's b cubed over b? B squared where? On the top. I could put it over 1. It's not necessary. And then 10 divided by 5 is 2. A cubed over a. What about my b's? B cubed. Remember doing those? Facile or difficile? Yes, we're loving this. We want a unit test on just these two sections, don't we? Yeah. Okay. Can we combine those? No, why not? Because they're all different. They're not like terms. So what? Ted, what was your question? If you would have taken out the GCF, it would have been 5AB, which would have left you A minus 3B squared plus 2A squared B cubed. And then we're back to canceling out a monomial over a monomial. 6 in one hand, half dozen in the other. Okay? It's the same thing. Same thing. I don't care how you do it, as long as you get the right answer. But you got to show some type of work. You can't just slap down an answer. All right? Now, here's another one. You do this one. 3x squared y plus 6x to the 5th y squared minus 9x to the 7th y to the 3rd over 3x squared y. You simplify that, and I don't care how you simplify it. Just simplify. I'm going to split it just because. Why not? I like to write things 400 times. It's fun. Minus 9x. Okay? What happens to that first fraction? Wrong. It is not a 0. It is a 1. Because 3 goes into 3 one time. 3 goes into 3 one time. Same thing for the x squared. Same thing for the y. So we got 1. How many of you made that careless mistake? Yeah, you got to put 1 there. Raise your hand because you made it too. Okay. All right. Don't make that careless mistake. What about the second term? 2 what? Plus 2 x cubed y. Very good. Very good. Minus 3 x to the 5th y squared. Right on? How many of you feel like a big old pile of poop work? How many of you feel like that today? Go ahead. It's okay. Yeah, y'all are pitiful today. Maybe I'm on my upswing and you guys are. It's time for school to be out. Do you think? We need a good cleansing snow. That's what we need. Freeze and wash all them germs away. That's what we need. You need to see what you can do about that. Mountain people, please. Please, please, please. Because if it were to do that at your house, it would take care of everybody else. Not that I'm wishing you to be stuck in your house for a week, but I'm kind of wishing you were stuck in your house for a week. I say that with love. It matters. Question? Yeah. Okay, say what? The lowest x and the lowest y. That's right. You just answered your own question. Good. Good. How many of you had that right? Very good. All right. So let's take this up a notch. That's so not a notch. That's so Candyland. Candyland. We're getting ready for some Monopoly. A little bit more brain power required. Are you dancing in your seat? Because it kind of looks like you're... Okay, don't anybody look at her. I know, don't do that. Question. Don't look at her. Stop it. Nothing? Okay. So you ready? How could this... Actually, we're not getting ready to play Monopoly. We're probably getting ready to play a little bit... Maybe Rook or Spades. A little bit more difficult than Monopoly, but not as difficult as chess, I would think. You'll take chess over Monopoly? All right, here we go. We're going to do something fun, and you guys are going to like it. Simplify 378 divided by 18 Shut up. It's impossible. Nuh-uh. No, it is not. I can remember sitting in the 4th grade crying because I could not figure out how to do this. And Andy could, and I could not, and it made me mad. And then I figured it out, and it was like, you know, the heavens opened, the angels came down. It was like, yes. What? It's not possible. You said it's not possible. How do we do this? Set up a house. Old-fashioned. Old-fashioned. Headlock. Atomic elbow. Yes, I don't know. How did you figure that out? Put it in the house. All right. What goes in the house? The 378. In the house. Write this down. Seriously, are you going to make us do this? This is, no, I'm making an analogy. You'll see in just a moment. Hey, what would we do? Yes, yeah. Mm-hmm. Yes. 378 is our dividend. 18 is our divisor, not that anybody cares or is listening to that part of the lecture. But how do I figure this out? 18 goes into 37 how many times? Twice. And then this is what you have to watch, folks, the process. And then we said 2 times 18 is 36. 37 minus 36 is 1. And then what? Bring down the 8. 18 goes into 18. 1 time. Boom. I know. 1 times 18 is 18. And we're going to subtract. And what is our remainder? 0. 0. What's our remainder? 14. No. The remainder is 6. All right, now, so that means our quotient is 21, right? We're going to do this very same thing with this. I don't know what example. 1. Here we go. We're going to use long division to find x squared minus 2x minus 15 divided by the quantity x minus 5. And we're going to like it. This is kind of cool how it ties in with just basic arithmetic. okay? But folks, and Courtney asked a good question, what's going to be inside the house? The first expression, okay? Are we really doing this? Did you do this in Algebra 1? For real? Okay, well, here we go. Oh, this is so much fun. What goes on the outside of the house? X minus 5. Oh, I'm excited. Aren't you excited? Megan, I can see that you are. Here we go. Y'all ready? Check this out. You got to watch. X goes into x squared how many times? All right, let's think of it this way. X times what gives you x squared? X. It has to go over the x term. So I'm going to put x here. Now, we're doing the same thing we did earlier. X times x is what? X squared. Move this. X times negative 5 is negative 5x. Draw your line, and then what are we going to do? We're going to change the signs. We're going to subtract, and this subtraction now becomes a positive. Okay, we got to change it because what did we do earlier? We had to subtract that number off. So we've got to do the opposite. X squared minus x squared is nothing. Negative 2x plus 5x is what? 3x. Now, just based upon what you did in the old problem, because what is subtracting a negative number? It's really just adding. So instead of subtracting all the way through, like I think Ms. Nowlin taught y'all this. Because I don't know, whatever the number was, and if it were a negative number, then you had to think subtract a negative number, I think. I don't know. Maybe I'm making it up. But I think just change the signs to the opposite. It's the same thing, okay? Based on the last example, what do you have to do now? Bring down the what? Be careful. The negative 15. Bring down the negative 15. Now, what do? We go through the same process again. X times what will give you 3x? 3. Well, what kind of 3 is it going to be? Is it going to be a plus or a minus? A plus, because it's a positive 3. 3 times x is what? 3x. 3 times negative 5 is negative 15. And what do we have to do now? Change our signs. Subtraction, addition. Hey, what's our remainder? Our remainder is 0. So what is the quotient? What is the answer to our problem? X plus 3. Okay? That's our answer right there. That binomial, x plus 3. Is there another way to do this problem? Why, yes, let's check our problem. And I do want you to write this down, Smarty McFarty. X squared minus 2x minus 15 over x minus 5. Do you guys agree with that? Can I write that problem that way? Yeah? First part of the semester, what would we do to that numerator? What can I do to, how? How can I separate? Unfoil it. All right, we got a factor. So I know it's x and x. Give me 2 factors of 15 that when you subtract give you 2. 5 and 3, right? Which one's positive? Which one's negative? Negative 5, positive 3. Oh, what can I do now? Cancel out my x minus 5s. What am I left with? Let me tell you something. Why do you think I'm showing you long division? Not to be evil. You got ready to say it because you're hateful butthole. That's what you got ready. I can see it in your eyes, Ben. Why am I showing you long division? Because we're getting ready to go into a different type of division. And if you understand long division, you will understand synthetic division. Okay? Ah, you will understand it. So, can you check your work doing this? Yes. Check your work doing that. But if I tell you to solve it using long division, you best solve using long division. Okay? Or hope for a multiple choice test where she can't tell what we're doing, right? Sneaky little turds. All right. Just think about that. Let's do one more. Ooh. Ooh. Sorry. See, y'all got it. Use long division. That's so gross. Stop laughing. That was not a very mature statement. Still that I'm laughing about it, it's not. I need to be professional. But class just would not be fun. What goes on the inside of the house? What goes on the outside? X plus 3 on the outside. X squared plus 5x plus 6. Folks, see what you can do with that. See if you can do that on your own. Here we go. X goes into x squared how many times? X times. X times x is x squared. X times 3 is 3x. Since it's positive, now I've got to go back and do what? I'm going to subtract my first term and my second term. Do you guys agree with that? My x squared's what? That cancel. 5x minus 3x is 2x plus 6, because I have to bring down my 6. And now we go through the same process again. X times what is 2x? Plus 2. 2 times x is 2x. 2 times 3 is 6. What am I going to do? Change the signs. There. Everything cancels. My remainder is 0. What is your quotient? X plus 2. How many of you checked it to double check and triple check? Good. Questions at all? How many of you did the long division like I asked? Because you better. All right, one more. This is going to look different. You don't have to complete this problem, but I at least want you to see it. If I were to give you a problem that said evaluate x squared minus x minus 7 times x minus 3 to the negative 1 power, that's kind of weird. But remember, if it has a negative variable, what's that negative variable? And first of all, that negative 1 goes with what? It only goes with this x minus 3, right? No, because it's an exponent. It's going to move it. Where's the fraction bar right now? It's there, but it's not there. It's under the terms, and there's a 1 there, right? It's there, but not there. Do you guys agree with me? Remember this, Lindsay? When you have a negative exponent, it's like it's magical, and it's going to move whatever that is with that negative exponent under the fraction bar. It's going to move it across the fraction bar so that it becomes x squared minus x minus 7 divided by x minus 3. Okay? And then if I were to tell you to solve using long division, that would be cruel, right? But then we would say x minus 3 divided into x squared minus x minus 7, right? And then we would go about our business. I'm not going to ask you to solve that because I want to give you your assignment. Okay? Just put it underneath, and now we're dividing. Okay? If there were a negative 1 underneath, move it to the top. And the 1 becomes a positive 1 exponent. Yes. Yep. All right, you ready? in your workbook, page. I'll type this in, okay? We've not covered quite all of section 6.2. On 10, 11, and 12, of course, I want you to use long division, okay? Don't be a slacker. Use it. Wow. If you can't get the point.